your preview for the optimization. Here is your review. First, here's all the answers, just so you can glance at the equations you would need real quick. And we can go and break each one of them down one by one to see how we do. And the answers you get are in yellow here. Now, to go one by one, starting with number 1 here. What we're going to do for this one, we are first looking, we are given 10 square meters. That is a surface area. So we're going to have something equal 10. The surface area of this box, and you have and we had the picture on the previous slide. I'll try to draw it again here real quick. Just something that looks, well, very poor. Let's try that again. So if we have this as our box, like that, we said it was x, x, and y, like that. So the surface area, there is no lid, so just the bottom part is x squared. Then we have 4 different faces that are each with an area of x times y. So 4x, y. My second equation is I want the volume. The volume is what I want maximized, and it's going to be length times width times height. So x times y. Now, I need to get y by itself in this first equation, because I can't have y in that primary equation. So y will be 10 minus x squared over 4x. So that's what I'll plug in here. It's x squared for the two x's times y is 10 minus x squared all over 4x. I'm going to simplify that and get these two x's canceling out. I'll still have an x here, and I'll have 10 minus x squared over 4 now. And I can simplify this even further just to bring that x in. So I'll have, it'll be 5 over 2x minus x cubed over 4. Now, at this point is when I would take a derivative. So when I take this derivative, f prime of x will equal 5 halves minus, that'll become 3/4 x squared. I now need to set this equal to 0. I'll have 3/4 x squared is equal to 5 halves. And from here, numbers get a little bit dicey, but you end up getting x squared equals 10 over 3, which means x would equal plus or minus the square root of that. Well, obviously minus isn't going to do us any good because, well, we can't have a negative length and possibly make a box. So the square root of 10 over 3 is what your value for x is. That's about 1.826. And then I would plug that into this to find what y is, and I should get y ends up being about 0.913 for that one. So there you go for number 1. Number 1 isn't as important, so I'm focusing more on these ones like number 2 and 3. The sum of a number, which I'll call x, and another number, 4 times that other number, y. So x plus 4y, because it's the sum, is 600, equals 600. We want the maximum to be the product. So f of x equals x times y. I can either isolate x or y, it doesn't matter. X would be easier, but just because we've been doing it, we'll get y by itself. So y is going to equal 600 minus x all over 4, which is the same as 150 minus x over 4. So I do the same thing here, plug that in for y. 150 minus x over 4. I'm going to expand it. 150x minus x squared over 4. Take a derivative. F prime of x will equal 150 minus that 2, x squared will become 2x. I'm still dividing by 4 of those, so now it will be 1/2 x. Set it equal to 0. 1/2 x equals 150, which means x equals 300. Make sure you go back and answer the question. Is that the number I'm thinking of? Yes. If I want to know the other number, y equals 150 minus x over 4, which is 300 over 4. So 100 minus 75, which is 75. Those are your two numbers. Number 3, very similar to number 2, except things are reversed. The product of two numbers is 625, and the sum of those numbers is a maximum. So again, I need to get y by itself. So y is 625 divided by x. Plug it in. 625 over x. Take a derivative. F prime of x equals derivative of x is 1. I can either do quotient rule for this, or another way I could rewrite this problem is 625 times x to the negative first, because I have the x in the denominator. So that means that when I take that derivative, 1, and this is going to end up being, when I bring this down, it'll be negative 625 x to the negative second power. I'm setting that equal to 0. I'm going to get this back into a quotient form, so that's a little easier. 1 minus 625 over x squared is equal to 0. It means 1 equals 625 over x squared. Cross multiply or multiply both sides by x squared, however you want to do it. X squared equals 625, which means x will equal the square root of that plus or minus 25. Now again, I'm going to say, well, yes, it's going to be a positive number here, so I'll say only positive 25 as an answer. So it means y will be 625 over 25, which means my answer here is also 25. Okay? On back, number 4. We're going to say, like, here's a barn, and I need to make this as my fence surrounding the barn. I know that is a absolutely terrible barn, but, deal with it. I'm going to say that these two sides are x in length, and this one is y. The perimeter from that fence, there's two x's and a y. It must add up to the 360 feet that we have. The other part of the equation that I want to maximize is the area. So again, x times y. Y getting by itself was 360 minus 2x. So I'm going to do the same with my primary equation. 360 minus 2x is what I'm plugging in. So that means that I'm going to expand it, 360x minus 2x squared. Take the derivative. Always take the derivative before you set equal to 0. That's an issue I've seen happen a lot so far. Minus 4x as my derivative. 360 minus 4x. Now set it equal to 0. 360 equals 4x, which means x will equal 90. And to get y, plug it back in to my original equation, which means y will equal 360 minus 2 times 90, and I get 180 as my answer. Number 5. All right, this problem, you're going to notice the numbers didn't come out exactly right. They will come out perfectly even tomorrow on your test. I've already checked and made sure, so no worries there. But the key thing about this one is that my volume function, length times width times height, or whichever way it is, if I plug that in immediately, h times 14 minus 2h times 10 minus 2h. There's only one variable showing up in there. So I don't need a primary, secondary equation. I'm already good here. So I'm just going to expand this through. I would first bring in the h into each. So I would get 14h minus 2h squared, still times the 10 minus 2h, and then do another expansion. And I end up getting 140h minus 48h squared plus 4h cubed. Again, it's only one variable, so I can take a derivative right now, and I would get 140 minus 96h plus 12h squared. I'm just going to rewrite it in standard form to get the h squared in front, 96h plus 140. Alright, now at this point, you would look, can I factor it? The answer is, in this one, no you cannot. The numbers you should get end up being like 1.9 and 6.1. Just so you can see how it would look, I'm going to change that to the 144 right there. So if I were to solve from here, I would try to divide everything by 12. And when I do that, because I'm setting this equal to 0, I'm allowed to do that, I would get h squared minus 18h plus 12. I'm sorry, not 18, just 8. That was dumb. h squared minus 8h plus 12 is equal to 0. And from there, I'm going to say, can I factor it? Well, yes, I can. Factors of 12 that will add, give me negative 8, will give me x minus 6, x minus 2, which means my answer will be x equals 2 or 6. Now, if my answer was 6, and I want to try to plug this back in, I would get a negative length here. If I fold it over 6 inches from here and from the bottom, it would overlap, and that can't happen. So that means that 6 is not an allowed answer, so 2 inches is my only possible answer for that. And you'll have that same thing tomorrow, where one answer will work, the other answer will not. Alright, finally, number 6. We have the garden being set up here, so same thing, but helps to draw your little picture. It's rectangular. I'll have x and y here. And we have, for a perimeter, we're going to have 2x plus 2y. That's what they want to maximize. That's my f of x here. My secondary equation is that the garden needed to be square footage of 1,600. So So x times y equals 1600, which means that by isolated y would be 1600 over x. So I'm going to bring this down here, and I'm going to plug in for y here. So f of x equaled 2x plus 2y. Plugging in for y, 2x plus 2 times 1600 over x. Simplifying 2x plus 3200 over x. Very similar to what we did in number 3 when I take this derivative. I can always say that this is still, instead of 3200 over x, it could be 3200 x to the negative first. And if that helps you in your derivative, then do it that way. So it would be 2 minus 3200 x squared. I'm setting it equal to 0. That's the same thing as 2 minus 3200 over x squared. It's still equal to 0. That means 2 will equal 3200 over x squared. Bring it back over here. I'm going to multiply by x squared and then divide by 2, or you can say cross multiply, whatever makes it easier. It'll be 2x squared equals 3200, which means x squared equals 1600, which means x equals the square root of that, which is 40. And then I would plug back in to my original equation right here, which means that y will also equal 40. Y equals 1600 divided by x, so y is also 40. So there you have it. Best of luck. You'll have 4 tomorrow. Numbers 4, 5, or 6 for sure, and one of them like either number 2 or number 3. Best of luck.